Good day, students. Today we are going to look into the Newton's laws of motion, and we are going to state the three Newton laws of motion, and then we will move on from there. The first law states that every body continues in its state of rest or of uniform motion in a straight line unless it is compelled to change that state by external impressed force. You get that? So, you see, it tells you that except a force acts on a particular body, all right, it will continue the way it is. Either it continues to remain at rest or it will remain in uniform motion on a straight line. All right. Okay, so that first lets us know that it is possible for the state of a body to change. All right, and it tells us that what changes it is a force. Are you getting what I'm saying? That it is a force that can change the state of a body. All right, so I think that is clear. So for example, I have a phone here, all right, and this phone will remain like this forever except I push it. You see, the fact that I push this phone, all right, it means I am exerting a force. Did you get that? I am doing what? I am exerting a force. Did you get that? All right, so then the second law, I want you to pay attention to that. It says the rate of change of momentum of a body is proportional to the applied force and is in the direction of the force. So the second law gives us the definition of force. I get what I'm trying to say. The first law tells us what force does. Force changes the state of a body. I get what I'm trying to say. While the second law tells us how to find the force acting on a body. So you are going to observe that a word is introduced here. The word momentum. Momentum. All right. So that takes us to what is momentum. All right. What is momentum, or what we call linear momentum? I want you to take note of that. All right. The linear momentum of a body is the product of the mass of the body and its velocity. So something like this. All right, something like this. Momentum P equals to M times V. Did you get that? The linear momentum of a body is the product of the mass of the body and its velocity. Can we move on? All right, so let's go back to the law. The rate of change of momentum of a body is proportional to the force applied and is in the direction of the force. So now let the force be F. Let the force be F. Okay, F is directly proportional to mv minus mu over t. Okay, all right, the rate of change. You see the word rate tells us that time is involved. All right, when you say the word rate, time is involved. That's why we said over t. Mv means the final momentum. Mu means the initial momentum. All right, the rate of change of momentum. So that's mv minus mu over t. So F is directly proportional to mv minus mu over t. Can we continue? All right, so looking at the laws of variation, we know we need to put k. All right, so we move this proportionality sign. We have F equals to k into brackets mv minus mu over t. Did you get that? Did you get that? All right, so that will tell you that mv minus mu over t, then there is a k. So we take k as 1. We take k as 1. So that tells you that F, I want you to pay attention to this with me. F equals to mv minus mu over t. So we have F equals to m into brackets v minus u over t. All right, this v minus u over t is acceleration. So we say F equals to ma. Are you with me? Because a is v minus u over t. So that is why we got the formula F equals to ma. Is that clear? It's so the second law gives us the definition, gives us the expression for finding the force acting on a body. All right, so let's go to the third law. Let's go to the third law. It says that, all right, action and reaction are equal and opposite. It says that action and reaction are equal and opposite. Okay, so in other materials you will hear for every action there is an equal and opposite reaction. All right, so it's still the same thing. For every action of a force, there is an equal and opposite reaction. So it tells you that every forces react. So let me give you an example. Okay, let me give you an example. When you have a block sitting on a table, something like this, a block sitting on a table, something like this, the weight acts downstairs. Downwards, sorry. The weight acts downwards. All right, this is the weight. It comes downwards. All right, using this third law of motion, it tells you that there is an upward reaction. There is an upward reaction. So for every force, there is an equal and opposite reaction. Is that clear? Is that clear? So that's very, very, very important that we understand. So I'm going to take just two examples today. Just going to take two examples today, and then I would give you a classwork that I want you to work with. That I want you to work with. All right. So let's take one example. Okay, a boy. Example one: a boy sits on a log. The mass of the weight of the log is 8 kilograms, and the weight, okay, the weight of the boy is 55 Newton. What is the reaction? What is the reaction of the ground? Of the ground on the log on which the boy is sitting. All right, you should try to take notes of this question. Write it down in your notes. A boy sits on a log. The mass of the log is 8 kilograms, and the weight of the boy is 55 Newton. All right, so let's find the weight of the boy. Remember that solution, that weight equals to mg. Weight is mg. That m is mass, g is acceleration due to gravity. All right, weight equals to mass times acceleration due to gravity. So we are going to look for the weight of the log. We are going to look for the weight of the boy. All right, we already know the weight of the boy. So let's look for the weight of the log. The weight of the log is what? 8. All right, 8 kilograms times g, 9.8. All right, which is what? 78.4 Newton. That is the weight of the log. Now, so what is the total weight? So weight of the boy and the log. Weight of the boy and the log equals to 78.4 plus 55 Newton. And that tells you that the 133.4 Newton, that is the total weight acting down. Pay attention to this. That is the total weight acting down. Okay, now pay attention to this. So let's say that this is the log of wood, and this is the boy. Okay, this is the boy. The boy and the log, would they both weigh 133.4 Newton? And so by the law of the third law of Newton, that says that for this force there's an equal and opposite reaction. So the reaction will be 133.4 Newton. Is that clear? The reaction will be the same as the weight, and it will be opposite. It will be acting upwards. Is that clear? Is that clear? All right, so let's take another example. And then we stop just for today. Okay? A particle of mass 3 kilogram on a smooth surface is acted upon by a force F if the acceleration produced in the particle is 2 meters per second squared. Find the magnitude of F. Simple. Find the magnitude of F. Okay, so that's very easy. We have the mass, we have the acceleration, so we are looking for F. So solution, all right, F equals to mass times acceleration. What's our mass? 3. What's our acceleration? 2. So our F equals to 6. And what's the unit for F force? 6 Newton. Did you get that? All right, so we stop here for today. I want you to still go through it, and later I'm going to send a classwork for you to work on. Thank you, and have a beautiful day.